Hi, we are now in the part 2 of the topic volcanoes. This is Dr. Sandra Catane, your lecturer for today. Last meeting, we discussed about noxious gases, and our example is the carbon dioxide incident in Lake Nyos, Cameron in 1986. Our next would be the next hazard, which is lahar. The main hazard from this volcanic process is burial and erosion. On November 13, 1985, Nevada de Ruiz, a volcano 130 kilometers off Bogota, Colombia, lahars or mud flows engulfed the town of Almero, killing about 22,000 people. Small pyroclastic flows, the summit of the volcano, quickly melted the ice cap, forming lahars. Those lahars were traveling at about 50 kilometers per hour. The largest of the lahars moved through the river of Lagunitas at the eastern flank and reached the town of Almero. 2 hours after, most of the flows reached the town around the volcano between 8 to 10 p.m. when the people of the villages are asleep. Another example of this type of hazard happened in the Philippines. On December 2006, lahars flowed on the slopes of Mayon volcano. Extreme rainfall associated with the passage of Super Typhoon Reming on November 29 to 30, 2006 triggered these lahars. Landslides and flash floods as well around Mayon volcano. This resulted to about 1,266 fatalities and extensive property damage. Mayon had no eruptive activity at the time of the disaster. You can see the lahars that flowed down the slopes of the volcano, and they can be recognized by the dark color in the map. The hard-hit areas were the southern part of the volcano. And as you can see in the other pictures here, the extent of the burial of the houses by lahars. And after the disaster, they were excavating, searching for possible survivors and remains of those that perished during that lahar event. The next hazard is crater lake or mountain lake breaching. I am going to present two examples in the Philippines. One is the September 6, 1995 flash floods that happened in Lake Maughan, Parker Volcano. The other one happened in Mount Pinatubo on July 10, 2002. Lake Maughan is a crater lake at the summit of Mount Parker. Mount Parker is an active volcano. On September 6, 1995, the landslide dam notch was breached, sending roughly 4 times 10 to the 7th cubic meters of floodwaters along the Ala River, killing more than 60 people. The lake level dropped to about 10 meters below the original level. To date, the trigger of the flash flood is unknown, but PHIVOLCS discounted the possibility of volcanic explosion as a trigger for these flash floods. The flash floods reach as far as Cotabato City. Our second example is the breaching of the crater of Mount Pinatubo in 2002. Triggered by antecedent rainfalls on July 10, 2002, the notch of Pinatubo volcano's crater, we call it Maraonot, gave way, releasing about 6.5 times 10 to the 7th cubic meters of floodwaters. As the notch is transected by a fault, it must have been the locus for landslide deposition in the past. Since the 1991 Pinatubo eruption, the crater water started to accumulate inside the crater, and it continued through the years and rise up to critical levels. And this narrow artificial canal was constructed in 2001 in order to deliberately induce a lake breakout so that hazards can be reduced. However, the canal failed to induce a deliberate lake breakout. The following year, during the heavy rains in July 2002, water rapidly deepened the notch by 23 meters, releasing an estimated of 6.5 times 10 to the 7th cubic meters of lake water. The flash flood killed one person and damaged two bridges in Botolan. In this photo, you can see that the lake level was reduced to this one, and this height is roughly 23 meters. You can see the lahars in the photo as well. These are pyroclastic deposits on this side of the volcano, but the white areas far behind are the lahars that were produced during that event. Debris avalanche and related hazards. The 1980 Mount St. Helens eruption was the most destructive in United States history. 57 people died and thousands of animals were killed, and about 200 houses were destroyed. On the morning of May 18, 1980, the largest terrestrial landslide or debris avalanche in recorded history reduced the summit of the volcano by about 400 meters. And this event triggered a blast. The blast is similar to a pyroclastic surge. Within 3 minutes, the lateral blast, traveling at more than 480 kilometers per hour, blew down and scorched about 600 square or cubic kilometers of forest. Prior to the debris avalanche, rising magma pushed the volcano's north flank outward at around 5 meters per day. In the morning, a magnitude 4.2 earthquake on the morning of March 20, 1980 signaled the reawakening of Mount St. Helens, the last eruption being 120 years ago. So we have like no eruption at all for about 120 years. The deposits in this photo is a debris avalanche deposit. These are the materials removed from the flank of the volcano. And this particular deposit is an avalanche deposit of another volcano in Russia, the Vesimiani volcano, in its eruption in 1956. You can see that the deposit is characterized by mounds, and this is a signature topography of a debris avalanche. It's called hammocky topography. Recent eruptions. The most recent eruption that happened in the Philippines is the Taal volcano eruption in January 12, just this year. Taal is the second most active volcano in the Philippines, with its 34th historic eruption on January 12, 2020. There are more than 30 vents clustered in the volcano island, excluding the submarine vents that are found in the base of the lake. The phreatomagmatic eruption of Taal volcano on January 12 was centered in its main crater. You can see that the main crater in this image captured by Copernicus Sentinel-2 shows the glowing crater of Taal volcano at that time. The volcano spewed ash about 15 kilometers high above the crater, and before the plume spread across Calabarzon and Metro Manila and some parts of Central Luzon and Ilocos region. The satellite image by Copernicus Sentinel-2 on January 23, 2020 shows the magmatic activity of the volcano as evidenced by crater glow that we can observe in the image. The ash-blanketed towns of Agoncillo and Laurel can also be seen on the side. This was taken in January 21, 2020. The previously water-filled crater lake of Taal, it's still dry at the time. This was the plume that was produced during the eruption. Philippine volcanoes. This is just a summary of the characteristics of volcanoes in the Philippines. Philippine volcanoes, we have 23 active volcanoes among the more than 400 inactive volcanoes in the Philippines. They are distributed in Luzon, Visayas, and Mindanao. The active volcanoes is shown in a triangle. It includes Pinatubo, Banahaw, Iriga, Mayon, Bulusan, Biliran in Leyte, Canlaon in Negros Island, Hibok-Hibok in Mindanao. We have here several active volcanoes, Kalatungan, Misoan, Ragang, Makaturing, and as far as the active volcano in Hulu Island, which is the Budaho. So anywhere in the Philippines, we have volcanoes, active and inactive volcanoes, except for Palawan, which have, there is a very young volcano there. It was estimated as about 30,000 years old, but it's not active. And the location of the volcanoes are quite in agreement with the location of the subduction zones in the Philippines. The most active volcano is Mayon with 58 historical eruptions. 7 active volcanoes are being monitored by PHIVOLCS. Most of the volcanoes are subduction related. However, there are some exotic types of volcano. The Amugis volcano in Palawan. Volcano monitoring. Volcano monitoring, the tendency is that scientists set up laboratories or volcano observatories on the sites or nearby the volcano, especially for active ones, to look for signs that the volcano is activating and may have an eruption soon. So what are they looking for? Normally, they're looking for signs of an impending eruption. As magma moves to the surface through the Earth's crust, it can alter its environment, producing signs that it's on its way to the surface. These signs are called precursors or precursory activity that may or may lead to a volcanic eruption. Precursors include 1. Increased earthquake in the area or increased seismicity. 2. Welling or cracking of the ground. We call this as ground deformation. If you have change in tilt, for example, or some areas become elevated or are raised relative to other parts of the ground. They also monitor the change in the amount of gas, or we call it as the gas chemistry and analysis that's coming out from the volcano, and change in the groundwater levels or chemistry. Volcano monitoring. Seismicity or earthquake activity, ground deformation, and gas output or gas monitoring, which can be done on a volcano or using remote sensing techniques, are the 3 most important precursors of an eruption. For example, the Montserrat Volcano Observatory in West Indies will increase the alert level and warn the population if two of these three precursors occur. This warning and increase in alert level may involve relocation of people and livestock to safer areas or ban on sailing boats within 4 kilometers of the volcano. Volcanoes and seismicity or earthquakes. What is the link of these two? Many erupts are preceded by increased levels of seismicity. The earthquakes are caused by fracturing and brittle failure of rocks, subsurface rocks, as new magma pushes its way up towards the surface. Earthquake activity is measured by seismographs. Seismographs are stationed on the flanks of the volcano, and there are also seismographs that are placed farther away from the volcano. Seismographs are stationed on the flanks of the volcano. These record the frequency, duration, and intensity of earthquakes and report it back to the volcano observatory. Changes in the seismicity, especially in increase, may forecast an eruption. Deformation monitoring. Any deformation on a volcano can be measured using GPS surveys or tilt meters. Tilt meters can measure tiny changes in the slope angle as small as 1 part per million. A slope change of 1 part per million or only 1 millimeter is equivalent to raising the end of a board 1 kilometer long. Still on deformation monitoring, why is measuring ground deformation on a volcano important? Tilt meters can tell the scientists when a new magma has entered a magma chamber in the volcano. Figure A shows the volcano in a dormant or resting stage. Tilt meters on the sides of the volcano measure a shallow slope angle. When new magma enters the magma chamber, as in figure B, the chamber swells to accommodate larger volume. This causes the sides of the volcano to bulge out. It's like blowing up a balloon. The more air you put into the middle of the bigger the out skin of the balloon gets. The tilt meters will now record a new steeper slope angle on the outside of the volcano. If fresh magma enters the magma chamber, this again may be a precursor to an eruption. New magma will increase the pressure in the magma chamber, causing more fracturing of the surrounding rocks. This will produce earthquakes and potentially the formation of a conduit to the surface. It is common for ground deformation and seismic activity to occur at the same time before an eruption occurs. Gas monitoring. When magma rises towards the surface, the decrease in pore pressure causes gases to exhale. As gas is released from the magma, it is often vents at the surface, leaking out small cracks in the ground or from the large volcanic vent. A dormant volcano will commonly vent gas even when there is no eruption going on. This is because the magma is deep down in the crust, still releasing gas, but not in the position to erupt at the surface. A change in the amount of gas release or the chemistry is another precursor to an eruption. An increase in the amount of magma in the chamber will produce an increase in the amount of gas. Also, the new magma may have a slightly different chemical composition to the old magma and therefore release different abundance of gas types like carbon dioxide, sulfur dioxide, or water. For example, an increase in the ratio of carbon to sulfur can be used to indicate the arrival of new batch of magma at the summit reservoir. Gas monitoring, still, gas or volatiles Um, gas composition and abundance can be measured directly from the volcano by gathering samples from the vent and fumaroles or using remote sensing techniques. For example, the amount of sulfur dioxide released by a volcano can be measured indirectly by correlation spectrometer or COSPEC. The spectrometer compares the light coming through the volcanic plume to a known spectra of sulfur dioxide, thereby measuring the SO2 levels of the plume. To summarize, what are the consequences of volcanism? Here are some bad points. Hazards, pyroclastic flows and surges or PDCs, pyroclastic fall or just simply fallout, debris avalanche or landslides, lahar, lava, tsunami, noxious gas, or crater breaching. However, there are good points of volcanism. We benefit from volcanoes, from their fertile soil, valuable minerals, water reservoirs, geothermal energy, and scenic beauty. This ends the lecture on volcanoes part 2. Thank you for listening and watching. Lastly, please read this warning. Thank you.